This video shows on how to solve linear first order differential equations. So we can say that the equation is linear if we have a form of dy over dx plus a function of x times y is equal to g of x, a function of g in terms of x. So this is the standard form for linear differential equation. So here, we have our example here. Find the general solution of x y prime plus 1 plus x y is equal to e to the negative x. So in order to solve this kind of differential equation, here are the steps for solving linear differential equations. First, we're gonna convert or simplify the given equation to the standard form, which is dy over dx plus the function of p in terms of y times y is equal to function of g in terms of x. Then the next step is find an integrating factor v is equal to e with the exponent of integral of function of p over x, which is this one, the function of p in terms of x dx. Then the third step is multiply the integrating factor v to the standard form. Here is our standard form, and then the last is integrate the derivative with respect of x of integrating factor times the dependent variable is equal to integral of function of g of x times the integrating factor dx. So going back to our equation, xy prime plus 1 plus xy is equal to e to the x. We can rewrite this equation as x is equal to dy over dx plus 1 plus x y is equal to the e to the negative x. So according to our first step, we're gonna simplify the equation to the standard form. So by dividing the given equation to the 1 over x on both sides, so we have dy over dx plus 1 plus x over x times y is equal to e to the negative x over x. So the next step is finding an integrating factor. So for integrating factor, v is equal to the e, the exponent of function of p in terms of x dx. So we have e integral of this will be our p in terms of x. So we have 1 plus x over x dx. Integrating the integral, 1x over x dx. This will give you an answer of, we're gonna solve this one. We can rewrite this as 1 over x plus 1 dx. So integrating this given integral, we have ln x plus x. So this is for integral of this one. Oh, I forgot the c, but you can neglect this c since it is a integrating factor. We can remove the c, ln x plus x. So our integrating factor is e to the power of ln x plus x, or we can express this as x times ex, or by simplifying, our v is x to the ex, x times e to the ex. Or v is x times e to the x. So the next step is multiply the integrating factor to the standard form. So dy dx plus 1 plus x over x y is equal to the e negative x over x, multiplying the integrating factor x e x. So the next step is getting the the integral of the derivative with respect of x of the integrating factor. So our integrating factor is x ex times the dependent variable. So what's our dependent variable? Our dependent variable will be y, is equal to the e to the x, integral of e to the x negative x over x times xex. Dx. This should be dx. So writing the equation. You can rewrite this as 1 over e to the negative x this is positive since so we can simplify this form, inside of the integral. We can cancel e to the x and the x. So what we have is dx xex y dx is equal to dx. So by evaluating this integral will lead you to xex times y. Then evaluating this integral will lead you to x. So we're gonna simplify this one, y in terms of x. So we have y x over x to the ex. So cancelling x, we have y is I forgot, we're gonna put the c in the other side. So this will be have c, since this is a infinite integral, so we're gonna put some c the other side, and you can neglect the c in the other side. So we have 1 over ex plus c. Sorry. So this is wrong. I got some mistake. So from the x to the x times y is equal to x plus c. This will lead you to x plus c over x e to the x. So maybe this will be our final answer. So this will be our general solution. So we're gonna summarize the solution. First, from the given equation, converting to the standard form, we came up with this equation. Then the next is finding a integrating factor. V is equal to the e to the power of integral of function of p in terms of x dx. So we came out our v is equal to x to the ex. Then by multiplying the integrating factor to the standard form, so this will be our standard form. Then this one is our integrating factor. Then the last step is integrating the derivative with respect of x of the integrating factor times the dependent variable. Then this is from our standard form and the integrating factor. So by evaluating, we came up this equation. Then by rearranging y in terms of x, we came up our final answer, the general solution, which is y is equal to x plus c over x times e to the x.